Hi folks, how you doing all? I hope you're exuberantly doing well. So, and I also hope that you had watched the previous videos so that your learning would be sequential way, like a waterfall method, not like a sprint way, like or agile method. So, just follow the waterfall method to learn properly and get more benefits out of it and learn it sequentially. So, all in all, let's jump in to the today's session. So, as usual, we will start with a question. What is a mission? So, after that, we'll come into the what is a computer, but before that, what is a machine? Take your time. Again, type your answer in comment section. I will look into it after some time. For now, what is a mission? So the meaning of a mission is either it may be mechanically or electrically or electronically operated device for performing a task. Our end goal, our output is to do some task. So that's what is called a mission. So then what is a computer? So before uh, we try to understand what is a computer, it's better to understand what is that type of task we do. So the types of tasks we do here is computing. So that's where the inventors made a computer. So computing is the act of calculating something, so such as adding it up, multiplying it up, or doing more complex math functions to it. So computers are named for this process. Basically, for that we have calculators, but we want to handle a huge amount of data information, and we want to do processing and a lot of mathematical operations, calculations, additions, multiplications, and some complex mathematical functions. So uh, that's where the computer came into the picture. So that's where, because they can actually compute faster than the most people, so that ever does they ever do. So the word compute comes from a Latin word for running. So so computing is a task, so that's clear. So the machine which does the computing is called a computing machine. In simple terms, a computer. That's it. So now these days, the term computing means the number of tasks that we do under or using computer has vastly increased. That's fine. But this is the fundamental definition of a computing machine. But to do all these missions, for example, a normal machine will have some physical parts which are interrelated. We call it kinematic pairs, and there will be a specific mechanisms, and because of these mechanisms, there will be a motion and then movement. So finally, we'll get something. So here, similarly, what are the fundamental blocks for a computer or a computing machine? So those fundamental block, the most important block, fundamental block for the computing machine is central processing unit, CPU. So central processing unit or central processor, or you simply call it as a processor. What it does, it process the data, it actually does the operations, it actually takes care of those calculations, it actually takes care of addition, multiplication, and the calculations with the more complex math functions. So that's what the processor is. But to do all those operations, you need to store the data, because you have to get the data from there, and then you have to do, for example, addition. After the addition of two numbers, again you have to put back the result of that addition. Where will you put it? From where will you take it? So that's our main memory. That's what we call a main memory. That's a RAM, random access memory. So this is a temporary storage. So when processing takes place, the transactions takes place in between your RAM and then central processing unit. This is what actually happens inside. But from where, how this processor or RAM basically communicate with the external world, because external world, without communicating with the external world you cannot take instructions, you cannot take orders. Then how can you serve those orders? For that we will use input and output devices. That's what our keyboard and our input device, mouse, our input device, or output device is our display or screen or printer. So this is how the overall way the data goes in and then stores temporarily for in the main memory, and then processor comes into the picture, processes it, and then calculates it, and then again shows the result back into the output device. Now, for example, once you switch off your laptop, what's going to happen to your data? Whatever you have typed, whatever calculations you wanted to do, additions or multiplication, everything will be gone in vain. So that's the reason there is one more fundamental block came into the picture, that is our secondary memory. So here this is a permanent storage. So here whatever data, whatever calculations, whatever computations you have done, if you want to store it permanently in somewhere, so you can store it in a secondary memory. Similarly, you can take it back to the main memory and use it in operations. So basically, so in short, your processor processes the data, the calculations, and then your RAM stores the data temporarily to provide as an input to your CPU. And similarly, your input and output devices communicate with other two systems. And then if you want to store all your computations or computing tasks permanently until you format it, it is the secondary memory is what does the work. So now we'll just look into the each building block of a computing machine uh, in brief. Okay, so now what is a processor? How does it made? How does it make? So basically what we have seen is what it does, but how it does, what does it consist of? There are plenty of questions should come into your brain. So now the base structure of a processor that transistors are built into is silicon. So this is our silicon. What is silicon? Silicon comes from sand after treatment and doping with some doping agents such as boron, phosphor, gallium, etc. We make a p-type and n-type semiconductor based on doping. So now, so after using this p-type and n-type semiconductor, you form a p-n junction. So what you do eventually, a p-n junction is formed when an n and p-type material is fused together to create a semiconductor diode. Very good, fantastic. But how this silicon is able to do a lot of operations that we are doing, and why we call it as a silicon, as a semiconductor? It's semiconductor, it's not fully conductor, it's not insulator. But why? So for that you just have to look into the electronic configuration, because everything in this world is by and large made up of some element, it doesn't matter, or combination of some element, those are called compounds. So now if you see silicon, the electronic configuration, the last valency electronic configuration is 3s to 3p2. The last orbitals, the p orbital, it's supposed to have, if it is fully filled, it should have 6 electrons, whereas it has 2 electrons. That means 2 orbits are partially filled, 2 shells are partially filled, the last one, and then out of which one is completely empty. So now what happens? That is the reason. These are it has unpaired electrons in it. So that's the reason it is able to excite. It is unstable. It is it's completely unstable. That is the reason it just wait for somebody to hook up. That's it. It's just wait for somebody to hook up. So that's the reason. So when you give a little bit of energy in both directions, either it can be converted as a conductor or can be converted as a insulator. So now we are getting this kind of material from sand. So now what you are doing after that? Once you fuse p type and n type semiconductor together, what you get is pn junction diode. Whereas if you add one more semiconductor, if you sandwich p, n and p, then what we get is pnp transistor. If you do it with npn, you got it npn transistor. Then so you name it as one leg as collector, emitter, and then base. So now what is the benefit of this? So now this transistor able to process various operations. So we are doing in our mission, basically in our computing machine, in computer. But how does it do? That's what the question is. How does it do? So in layman languages, in a layman language, it is electrical signal are getting converted into on or off in simple with zeros and ones. But how? Using transistors. But how does this work? So because a transistor is a sophisticated switch with higher controllability using gate voltage. So here what we see is base. So normally a switch you will have on and off. For that you need to provide a manual input. If either you have to put it on or off with your finger, whereas a NPN transistor can be operated through a base, through other gate voltage. So now you can put on or off. You can put on or off of your computer of your transistor using electrical signals. So by joining the huge number of transistors using logic gates such as AND or NAND or NOR gates, we can do the operations that we are presently able to do. So this is how a sand is being turned into your computing machine. Fantastic, brilliant story. But what does this processor consist of? Because a processor is nothing but a number of transistors. But what does a processor consist of? Basically, how they make it. Uh, a processor consists of arithmetic logic unit, a floating point unit, a registers, and cache memory. So arithmetic logic unit basically deals with int type of data, and then floating point unit basically deals with your floating point numbers. Similar, these are two core data types in Python. And so together the arithmetic logic unit and floating point unit perform all of the mathematical and logic operations of computer processors. So because they are used they're used so prominently, they fall in the critical path of the central processing unit. So now what's next left is registers. Registers are small amounts of high speed memory contained within the CPU. They are used by the processor to store small amounts of data that are needed during the processing, such as example, the address of the next instruction to be executed, the current instruction being decoded, the results of calculations. Now the last one is cache memory. Cache memory is a small amount of high speed random access memory built in directly with the processor. We know what a random access memory or main memory does. Similarly, cache memory does the same thing. It's used to temporarily hold data, and instructions that the processor is likely to reuse. This allows for faster processing as the processor does not have to wait for the data and instructions to be fetched from the RAM. So this is all about your processor. So now what we look into is RAM. So RAM, as we all know, it is also made up of transistors, but a little more addition is consists of an integrated circuit, which is the circuit is made up of millions of transistors and capacitors, which are extremely small in size, and each transistor is lined up with a capacitor to create a very compact memory cell so that the millions of them can fit on a single memory chip. You can see, basically see, as we are using the words such as millions, you might think it could be a huge one, but don't get into that trap. It's as smaller as that can fits in your hand. So this is the typical RAM that looks like. So now this is how the RAM looks like, and it does the most important task. That's a temporary storage area, the temporary memory for our computing operations for our computer. So now the second one is ROM. So basically this is our hard disk. We call it as a computer hard drive. So it is a one kind of technology that stores the operating system, applications, and data files such as documents, pictures, and music that your computer uses. So most of the things will be stored here permanently until unless you format that space. So now the question is not that how does this work. So basically we know HDD. This is the famous one. We have been using it. So what is hard drive and how does this a mechanical one works? Typically it consists of a platter that contains compartments, different compartments to hold the data, and so it will have an arm. You can see this arm. This arm moves across the platter to read or write the information requested. To make this process faster, the platter spins as the actuator arm moves across it. So far, so good, brilliant. And that platter or disc is made up of aluminum alloy of glass and coated with a magnetic material. Fantastic. But how does it able to store the data? If it is a transistor, we know you can put it on or off using electrical signals. That's the reason you can do it well. So but here it's a magnetic material. Both are mechanical parts. One is rotating, other one is touching the rotating platter. How does it work? So that's where you should know the concept of spin quantum number. So this is how. So electron spin or spin quantum number is the fourth quantum number for electrons in atoms and molecules. So this the electron spin is constituted by either upward direction, that's called plus of milliseconds, or downward direction, which is negative, minus of. So these are the two arrows how we define the electron spin. Now how exactly it stores the data is, the hard drive contains a spinning platter that we have discussed with a thin magnetic coating that we had discussed. Now an arm which moves over the platter, it actually writes zeros and ones as tiny areas of magnetic north or south on the platter. To read the data back, the head goes to the same spot and notices the north and south spots flying by. So and so deduces the stored zeros and ones. So now actually if you look into this, say as we have discussed before about the silicon, it consists of in last orbit it has a different number of electrons, and some are unpaired and some are paired. When when any shell is paired, for example 1s, if it is completely paired, then their spin will be balanced because one is clockwise, other one is anti-clockwise, so completely balanced. Whereas if it is not completely filled, in that case it is going to be, it is going to be uh, a magnetic material. So that's how depends upon whether it is fully paired or unpaired. Based on that, the materials become magnetic or diamagnetic or paramagnetic. So now here how this stores the data is, when the arm the arm which touches your platter, in that case basically it is magnetizing your electrons. In that case, the unpaired electrons whichever is there, that either can spin in clockwise or in anti-clockwise. That's nothing but 0 or 1. The game is over. That's it. It will rotate it either in clockwise or anti-clockwise. Once it takes that position in certain storage block of in your HDD, in your rotating disk, that until unless again in that spot, if it is demagnetized, the data is not going to be gone anywhere. So that's the reason it will be permanently stored there. So now this is how, using the spin quantum number, using the spin of an electrons, we store the data permanently. But this is little slow, and it takes a lot of time. Of course you can store huge amount of data, but to storing data it takes a lot of time. So then the new thing has research has gone, and then new type of hard disk has come into the picture. So that's called SSD, solid state disk. So it's made up of several memory chips installed on a circuit board. Same, it consists of again silicon wafers similar to our computer, that microprocessor. So this is how it looks, and so the working of this SSD is as similar as to the a normal random access memory, because it also consists of a transistors, and then the fundamental working procedure remains same. Then, so basically with this we have covered the basic fundamental blocks of computing machine. So from RAM, ROM, and then processor, whereas input and output device is not that important for us to discuss here, because these are all uh, things to give instructions and then take results. So I hope you enjoyed the session, and keep watching it and keep subscribing it, and then just sit and relax for the new information. Thanks, and see you again.